So after this, we will have a more complex feedback structure for distillation column, where we will consider 6 variables for feedback, right? We will consider 6 variables for feedback. So we will draw a fresh diagram here. So this is our distillation column. So this will be a cylindrical structure, right? This will be a cylindrical structure. And here there will be number of trays. There will be number of trays. Okay, so here the first variable which we will consider, here we will apply the feed. Feed will be given to the mid tray with flow rate F and composition Z. Then here we will consider the first variable. So the first variable which we'll consider, that will be pressure at the top tray, right? This is our first variable, pressure at the top tray. Okay. So we know that here we take out the vapors from the top tray, and this we will provide to the condenser for condensation, and then this will be stored in the reflux drum after condensation, right? So pressure at the top tray, this is also a controlled variable, right? So for the feedback control of this, what we do, so first of all, because the pressure at the top tray, here this is the pressure at top tray. This is our first variable. Okay. So we are going to measure the top tray pressure using a pressure transmitter. This will be our pressure transmitter. So we'll measure the pressure, and then this pressure will be compared with the set point pressure. So this is here we have plus, here we have minus. So plus minus, and this is the pressure set point. This is the set point variable for pressure, and then the error will be given to the controller, and we will have pressure controller here. This is the pressure controller PC, and this controller controls the valve at the outlet. So this is these are the vapors going, and here we will have a valve which will control the opening of the vapors. So this is the valve. This is the valve, and we have connected this to pressure controller, right? This is the first feedback loop for the pressure, and here the control variable is pressure at the top tray. Right, so here what we did, because the supply of the vapors which you are giving to the condenser, that could not be random, right? That could not be anything. So that also must be controlled. So that is why we have applied a feedback loop at the top tray of the distillation column. So here the pressure at the top tray will be measured by pressure transducer or the pressure transmitter. This will be compared with the set point value. An error will be generated, and that error will be given to the pressure controller. And this pressure controller gives the control signal to the valve. And valve will be there on the supply line of the vapor supply line. Right. So this is the vapor supply line. This is the vapor supply line to the condenser. Right. This is the first feedback loop. Right. After this, we will go to the condenser. Right. So here we will modify condenser a bit, and we will use here heat exchanger. So this is heat exchanger, and this will condense the vapors, and this will gives us fluid or liquid which we will store in the reflux drum. Right. So for this heat exchanger, for removing the heat, we will have here, there will be a supply of coolant. There will be coolant in and coolant out. Right. And after this condensation from the heat exchanger, the reflux will be given to the reflux drum. The fluid, the accumulated fluid or the liquid will be given to the reflux drum. Right. So here the temperature of the reflux is our second control variable. So this is T is the temperature of reflux. Right, so this is our second control variable. So this temperature should also be maintained. Right, this could not be random. This should be maintained. Right, so for this, what we will do, we will apply feedback control here. So for this, we will measure the output variable. This is the output reflux. This is our control variable. So we will measure the temperature here using temperature transmitter or temperature transducer. Right, this will give us the measured control variable. Now this measured control variable will be compared with the set point value. So this will be compared with the set point value. So suppose this is the set point value. This is T set point. T set point. I hope you can understand this. T set point. Right. So this will be plus and this will be minus. You can do it. This will be minus. Okay. So now the error will be generated. Error will be generated and error will be provided to the feedback controller. So the concept is very simple. If you know the concept that you have to do, you can easily draw the diagram. Right. So here, this is our feedback controller. So here we call it temperature controller. right? And then you can see here that we have a coolant supply, and on the coolant supply we will use wall. We'll copy this ball and we will place it in the coolant supply. So now we have a wall, the coolant supply, and this controller is giving control signal to this wall. This is the coolant in. So this is the feedback loop for temperature of reflux. To maintain the temperature of reflux, we have, this is coolant out, this is coolant out. Right, so what we did here, we have after condensation we will get fluid accumulated as reflux in the reflux drum, right? So we have to maintain the temperature of this reflux here. So this is our controlled variable. So we will measure this controlled variable using temperature transducer or transmitter or some measuring device, and this will be compared with the set point temperature. Error will be generated and this will be given to the controller, and controller will give control signal to the wall so that the coolant supply can be maintained, can be increased or decreased based on the requirement. Okay, now we will move ahead. Now we have this reflux drum. This is our reflux drum. Okay, we have accumulated liquid or fluid inside this reflux drum. This is reflux drum. Okay, so now our third variable is the liquid level of this reflux drum. So level of reflux drum will be our third variable. It's because this should not be over flooded. So this will be our third variable. Okay, so here this is also similar to what we have done earlier. So here we will measure the level of reflux inside the drum. We should measure from here. So we'll measure this using level transmitter. This level transmitter, we will measure this. Then this will be compared with the set point value. This will be compared with the set point level, liquid level. So we'll have plus here and minus here, and then this will be, this we can write LSP. Here we have written TSP, that is okay. Here also we have written now. So after the comparison, we will get the error, and this error will be given to the controller. So now here is our controller. So this is level controller. Now level controller controls the liquid inside, fluid inside this reflux drum. So we'll draw a valve here. So we are drawing valve. So controller gives control signal to the valve. And this valve will increase or decrease the opening so that the liquid level inside this reflux drum can be maintained. So this was our third variable. Okay. After this, we'll move ahead. And after reflux, what happened? What will happen after reflux? After getting the reflux in the reflux drum, Ankit Yadav, what happens after this? Ankit Yadav is sleeping after joining the class. Okay, Nitin, what happens after
Yes, sir.
reflux drum? Yes. After getting the reflux, what will happen in the distillation column?
Uh,
Okay, okay. Avnish,
So there is two things. One is we collect the top product, and other is we feedback to the distillation column.
right. So after coming here, some part of the reflux we take out as a product that will be distillate, and some part we recycle back with reflux with flow rate R to the distillation column. You can see here, kahan gaya? Yes. So some part we will taking out as a product here D, and some part we will recycling back with flow rate R. Okay, that was reflux. This was recycling back. So now our fourth variable will be, and here as we know that some part will take out as a product, some part will be recycled back. So this ratio is very important, that how much you are taking out and how much you are recycling back, right? So D by R ratio will be our fourth variable. Now we'll be coming to the fourth variable. So this will not be single variable, this will be a ratio of D and R. So we know that after reflux drum, some part we take out as product and some part we recycle back to the distillation column. So how much part we will take out as a product and how much part is being recycled, this should be controlled. This could not be random. So that is why we'll apply control here. So for applying control here, so first of all, we will have to measure the controlled variable, right? So that means here there is no single variable, there is a ratio D by R. So that means we have to measure the D by R ratio, right? So we will draw it. So this side we have R. R is the flow rate of reflux which is being recycled, and D is the flow rate of distillate. Okay. So now here we will measure the ratio of D and R. So here this will not be exactly feedback control. This is a special type of control which we will read, which we will study later on. This is a type of ratio control. This is a specific control which is an extension of feedback control. So in feedback control we measure a control variable, but in ratio control we measure the ratio of two variables, right? So this is the reflux which is being recycled at the top tray, right? And this is the distillate, right? So here we have measured the ratio using ratio transmitter. Then this ratio will be compared with the set point value. So here set point ratio. So here our set point is the set point for this variable. So plus and here minus, right? So we will get the error in the ratio. So here we are getting the error, and then this error will be given to the controller. So this is the ratio controller, right? And then ratio controller will give the control signal, and the control signal will be given to the valve, the final control element, right? So we have a valve at the distillate here. Suppose this is a straight line, and this is a control signal given by the controller to valve, right? So this is not looking better. So what we will do, this should be here, here. Now this is good. So yes, so the ratio controller gives the control signal, and this will be given to the valve. Valve is acting as final control element, and this will control the D by R ratio. So this is our fourth variable, right? So this is D by R ratio. After this, yes, these four variables are over. So now we are moving to the fifth variable. So fifth variable will be the flow rate of reflux. So F is our fifth variable. This is the flow rate of, not reflux, this is feed, right? So flow rate of feed is the fifth variable. So this should also be controlled. This is obvious that the supply of feed cannot be random, right? So this should be controlled. So now we are going to apply a feedback loop here. So we will measure the flow rate using flow transmitter or the flow meter. This is flow transmitter, and then the structure will be same. This will be compared with the set point flow rate. This is the comparator, and here we have, this is the flow rate set point FSP. This is plus, this is negative feedback, so minus. Okay, and then the error will be generated, and this error will be given to the controller. This is the flow controller, and then there will be a valve. Do we have any valve? So we'll copy this valve, but we'll have to rotate the knob. How can we do it? Can we flip it? Flip. Oh, no, I don't know how to flip it. Oh, rotate was there. Okay, no issue. We will draw it. So now we have a valve here, right? And then the flow controller will give control signal to the valve, and this feed flow rate will be controlled. This is our fifth variable. Then our sixth and final variable here will be the concentration we are saying here Z, right? So this is the concentration or composition of feed, right? So this will be our sixth variable. So we will shift this diagram to the right a bit so that we can have some space. Yes. So Z is our last variable. So similar thing will be done here. Okay, here we'll apply, we'll add one more thing here, that this is the feed supply, and here we will add one more thing, and this is, do we have a triangle? This is, I'll tell you once I draw it, the drawing will be complete. So we call it, so this is the schematic for constant displacement pump, right? So the constant displacement pump gives a constant flow rate of the supply, right? Or we can put it here. This is the constant supply. This is the main supply. Main supply of the feed, right? So now what we have to control the concentration. So definitely, obviously, we will first measure it. So we will measure it using a concentration transmitter or the composition analyzer. So this is our concentration transmitter or the composition transmitter, and then this will be compared with the reference value. Then the error will be generated. This is the reference value C SP. This is simple. We are doing the same thing again and again, so there should not be any doubt in this, I hope. So this is the concentration set point. Error will be generated. Error will be given to the controller. Here we have controller, concentration controller, right? So here we cannot, like in the other cases, this feed we suppose we have to control the feed flow rate. So we can measure the flow rate, then we can apply the control signal on the same feed, because by increasing or decreasing the opening of this valve, feed flow rate can be increased, right? But here in case of concentration, you cannot increase or decrease the concentration using by putting a valve on the main supply. This will only increase or decrease the flow rate, not the concentration. Okay, so that is why to maintain the concentration, we need an auxiliary supply. So this is the auxiliary supply. Okay, and here on auxiliary supply, we'll apply a valve. So we have a valve here. We'll copy this valve and we will apply it here. Right? So the controller will give control signal to the valve, and the placing of the valve will be on the auxiliary supply, because we cannot increase the concentration or decrease the concentration using the same supply, right? And this was main supply. This was main supply, right? So this is our sixth variable. Okay, so these are the four controlled variable which we can apply on the distillation column. So first is the pressure at the top tray, then temperature of the reflux, then level of reflux drum, then D by R ratio, then concentration of the feed. Okay, so these are the six variables which, so we have covered feed forward, inferential, feedback, and 6 feedback loops.
Thanks for watching. Master Control. Master the future.